Assalamualaikum warahmatullahi wabarakatuh. My name is Abiyu Ramadhan, and I will explain the first two cells of the project. First is the library import cell. This is where the library is being imported. I will actually be fast in this. There's a PySpark, Matplotlib pilot, Seaborn, Pandas, and NumPy, sklearn, and then also an installation of the Spark session. Yeah. There. The second cell is the data simulation, where we actually where we going to simulate all of the we're going to simulate the the the, the accident street. First, we also first of course we have to import the random seed. This is for the data will not being too perfect or too stiff. And then we actually going to print the simulation data, and the rows is we use is 800. And then here is the variable of the variable where each of these variable will contribute to if may or may not the accident happening. So there's a day, hour, weather, traffic density, average speed, sound speed, stop duration, and light level. Also, there is location for extra detail. And this is where the logic of the each of the variables. So sound speed is if the higher in 65, the risk score will be 1, and if the risk score is higher than 3, the accident will be happen. If not, there is no accidents. And for the randomizer, the random seed earlier, we use the 7% of it. 7% noise is for the randomness. And then the last and then there's here is the data simulation. As you actually can see, the higher traffic density, express speed, sound speed, stop duration, and light level, the most likely to be an accident. That's all from me.
Hi everyone, my name is Iqbal Taufiq with student ID F1D023100080. Today I'm going to walk you through our pictures engineering process. The goal of this code is to transform our raw multi-column data into a standardized format that our machine learning model can actually understand. First, step A, we define our input variables such as weather, traffic density, and average speed. Spark algorithm cannot process this as separate column, so in step A, we use the vector assembler. This transformer merges all these independent columns into a single vector column named raw pictures. Think of it as packaging our data points into one box. Next, we move to step B, the standard scalar. This is crucial. Our data has different units. For example, average speed might be 0 to 100, while light level could be in the 1000. Without scaling, the model would be biased toward the largest number. By setting mean and with STD to true, we normalize the data to standard distribution or z-scores, putting all the pictures on a level playing field. In step C, we wrap these stages into a pipeline. This ensures that the assembly and scaling happen in a strict order. We call .pit to let the pipeline learn the statistics like mean and variance from the data, and then .transforms to apply those changes. The result is the f_prepared, which contains our final pictures vector. Finally, in step D, we split this prepared data. We allocate 80% for training and 20% for testing. We use a seed of 42 to ensure reproducibility, meaning if we run this again, we get the exact same split. And that's it, we have successfully converted raw data into standardized vectors, and we are now ready to feed this into our machine learning model.
Okay, we are now in section 4, which is in the classification modeling using random forest to detect accident, and I, Pinka Dima Calista, will explain this section. So first, we initialize the random forest classifier, and we configure it with our standardized filter, and setting the num trace to 50 and limiting the depth to 7 to ensure stable performance. In the line RF model equal RF fit train data, train the model using our prepared data, and then we generate prediction on the test set, and then we evaluate the model using the multi-class classification evaluator. First, we calculate accuracy. The output shows a strong accuracy of 85%. Next, we calculate the F1 score, which is a crucial metric for balance assessment in classification tests. And the result is an F1 score of 80.45%. And finally, we display the feature importance, an array showing the weight of each input features to help us understand which sensor data contribute most to accident detection. Thank you.
Hello, my name is Muhammad Anshar Putra and my last digit name is 078. So in this section, we present the visualization used to evaluate performance of detection classification built in a random forest algorithm. So the visualization consists of the two main parts. The first one is confusion matrix, and the second one is the feature important charge. So the confusion matrix is used to measure how well the model classified accident and non-accident condition. The vertical axis is represent the actual conditions, so, while the vertical axis prediction how the represent the model prediction. Based on the result, there are 67 data points that were correctly predicted as non-accidents, um, and 52 data points that were correctly predicted as accidents. However, there are still 17 accidents cases that were not successfully detected by the model, and 4 cases that were incorrectly detected as accidents. So the second one is the second visualization is the feature important charge, which show which feature have the greatest influence of the model's decision-making process. Based on the result, there are three feature. The first one is the vehicle stop duration. The second one is the light level, and the third one is sound peak. This means that the long vehicle duration on the road, a low lighting condition, and a high collision sound intensity play a dominant role in accident detection. So thank you.
Okay, first, this session will argue spatial visualization to show the simulated action point on a map of Mataram. First, a subset of column is selected from the Spark data frame so that the data can be used directly by the plotply or this line of code. Next, random latitude and longitude values are generated within a defined range, representing the approximate geographic boundary around Mataram, okay, allowing each record to be plotted as if it occurred at a real location using an NP-random uniform. This one. Because the original oxygen label is still numeric, the code maps the values of 0 and 1 into readable text, namely tidak kecelakaan and kecelakaan, so that the legend and tooltips become more interpretable when constructing the map with PX scatterbox. Only a random sample of 300 rows is used to keep the visualization clean and avoid overlapping point. The parameter latitude and longitude define coordinate of each point, while color use the accident status so each category appears in different color. The size of each point is scaled through the traffic density, representing how crowded traffic was at the time. However, information is also added, including traffic density, average speed, sound peaks, and stop duration, so user can inspect each location interactively. And finally, map size is defined so that the zoom level and theta are set before calling figurative show here to render the accident simulation map for the Mataram area. And lastly, it's the conclusion. For the conclusion here, first we state that the random forest classification method was successfully implemented to detect accident even using simulated sensor information such as traffic condition, noise level, stopping duration, weather, and lighting. The model achieved an pretty good score here, which indicated that the prediction system is reliable enough to differentiate between normal traffic situation and potential accident in the simulation. The result also highlights several key contributing features, including collision sound, peaks, and length of time vehicle state stop, the level of lighting, as well as traffic density and driving speed. Finally, in the context of smart city approach in Mataram, this model could be integrated into a complete IoT data pipeline, starting from sensor device, flowing through Kafka and Spark streaming, processed by an action API and stored in ADFS, so that the accident detection can run in real time and automatically notify emergency service such as PSG or others. Okay, maybe that's all from me. Thank you.